I'd like to talk to you a little bit about the characteristics of a quadratic function. In order to do this, I'm going to use the equation f of x equals x squared. This is what we refer to as our parent function. It's essentially a quadratic function without any transformations at all. We already discussed this a little bit in class. I want to remind you that when we looked at a quadratic function, it had a U shape. So it looks something like that. This U shape is called a parabola. If I were to graph the function f of x equals x squared, I'm going to use this sheet of paper here, you would get your coordinates by using the x values and plugging it in to our original equation, f of x equals x squared, to get the y values. Okay? If I use the x value of 0, 0 squared is 0, so I have the point 0, 0. Using an x value of 1, 1 squared is 1, giving me the point 1, 1. Using the x value of 2, 2 squared is 4, giving me the coordinate 2, 4. An x value of 3, well, 3 squared is 9, so I have the coordinate 3, 9. This gives me the right side of my parabola. And that U shape creates symmetrical points. So if this is the right side of my parabola, the left-hand side will have points that are equidistant to my axis of symmetry. So in my parent function, the x-axis, or excuse me, the y-axis is something we call our axis of symmetry. The point 1, 1 would become negative 1, 1 on the left-hand side. The point 2, 4 would become negative 2, 4 on the left-hand side. The point 3, 9 would become negative 3, 9. See how these points are equidistant. 1, 1 was right 1 unit, now it's left 1 unit. 2, 4 was right 2 units, now it's left 2 units. 3, 9 was right 3 units, now it's left 3 units. Okay. Whenever we have a quadratic function that has an a value of 1, meaning that there's no stretch and no compression, you're going to see a pattern. The pattern is going to be how we move from one point to another. Now we're going to start off right here at the point 0, 0. 0, 0 is what we call the vertex of the parabola. A vertex is either the highest or lowest point on the graph. So starting at the vertex 0, 0, to get from this point to this point, I need to move right 1 and up 1. To get from my point 1, 1 to my point 2, 4, I have to move right 1 and then up 3. To get from 2, 4 to 3, 9, I have to move right 1 and up 5. So far, we've seen each time we are going to be moving right 1 unit. That's consistent. But what changes is how much we move up. We went right 1 up 1, right 1 up 3, right 1 up 5. So when we move up, we are moving up by increments of odd numbers, not the same odd number each time, increasing odd numbers. So 1, 3, 5. To get from this point to the next point, would it actually move right 1 up 7, and then right 1 up 9. And we can keep doing this forever because a parabola will go on forever. Also, I want us to practice domain and range. Once again, some of you struggled with this in our chapter 1 section. Domain will actually always be the same for all parabolas. Domain will be all real numbers. Or remember, you can write it as negative infinity to positive infinity. This is because as we move to the left and as we move to the right, the function will always be defined. And a parabola, like I said, it goes on forever. The range, however, is restricted, and it's restricted because there's a max or a minimum value. In this case, we have a minimum. Range must be written down to up, so the lowest point of my graph is here with a y value, because range is y, a y value of 0. I need to use a bracket because 0 is included in my graph. And as the function moves up, it's going to go on forever, meaning it's approaching a positive infinity that I need to use a parenthesis with, because positive infinity cannot be reached or obtained. So it's not included in our graph.